In this video, we're going to be talking about exponential functions, but we're going to talk about how to create exponential growth and decay models using two formulas. So previously we talked about that y equals a times b raised to x. And if you remember, we said the a is the initial value. That is not going to change. So we have two models when it comes to growth and decay. So if you notice, the main difference between these two models is the plus and the minus. This is very essential because when you do growth, you've got to add. When you do decay, you have to subtract. So my a value is still going to be my starting value, my initial amount. So when we look at the growth model, my a is still being multiplied in the front. That's not going to change. What is going to change, and not really a change, but we're going to give more detail to, that's going to be your base. So my base is my multiplier, and what's going to happen is my base, we're now going to break down. My base is now going to be 1 plus or minus r. It can be the plus for the growth. It can be decay for the decay. Minus for the decay. So my base for growth is going to be 1 plus r. That whole thing in the parentheses is going to become my base. Or with decay, it's going to be 1 minus r. That's my whole base. All right, so what you need to understand is my base, we're breaking it down and we're calculating the base based off of the information that's given. Now, what does r stand for? So my r is part of this formula. Now, my 1 value is always going to be there. It's always going to be 1 plus or 1 minus, and that has to be done. So when you're calculating these, it's always 1 plus r, 1 minus r. But the r is going to represent the percentage. In your problems, it's going to give you a percentage. However, we have to write the percentage as a decimal. So if they give you a percentage, your percentage rate, in order to write it as a decimal, you have to divide it by 100. So if I give you 15%, we would divide 15% by 100 and plug it in as 0.15. And then finally, the last thing that's going to go into our formula is when we go to calculate our exponent, normally our exponent is x, and that is still true, but we're actually going to substitute in for x now. These are going to represent some type of time frame. That's going to be your input value. So it could be in times, seconds, minutes, hours, and days, or years. Okay? So with doing all this, again, the a value is still going to be your initial value. Okay? That's still going to be the same. Your rate is the percentage that's given to you. Okay? You're going to divide that by 100. And my x is the time frame that they're asking you to calculate. And all of the 1 plus r's and the 1 minus r's represent the base.